Problem number 18. A uniform disk is being pulled by a force F through a string attached to its center of mass. Assume that the disk is rolling smoothly without slipping. At a certain instant of time, in which region of the disk, if any, is there a point moving with the zero total acceleration? Solution for problem 18. Let's check all four regions for this condition. Let's take region 1. Basically, we have three kind of accelerations. One acceleration is for all of points, which is equal to force divided by mass of this disk. It's going to the right. Also, we have tangential acceleration compared to disk, and also we have centripetal acceleration, which is going to the center of this disk. And from this point, let's check what happened to region 1. In region 1, we have tangential acceleration going to the right and down, and centripetal acceleration going to the back and down. It means that in this region there are no acceleration which are going up, and the total acceleration cannot be zero. In region 2, we have tangential acceleration going right and up, and the centripetal acceleration going right and down. So all accelerations are going right, so it cannot be zero. In region 3, we have tangential acceleration going up and left, and the centripetal acceleration going up and right. So it means that the total acceleration going up, and it cannot be zero. And let's check region 4. In region 4, we have tangential acceleration going down and left, and the centripetal acceleration going up and left. So it means that centripetal acceleration can cancel tangential acceleration. And also, both of these accelerations, they can cancel acceleration of whole body to the right, because tangential acceleration which is going to the left, it's always less than total acceleration of this total body. So it means that if we have a centripetal acceleration which is omega square r, we can use angle and distance from the center to create any possibility for acceleration in direction up and left. So we have two parameters which we can use to cancel even acceleration total and tangential acceleration. So it means that in region 4 we can get points with zero acceleration. And this is answer D, correct answer. It was solution for problem 18. Problem number 19. A puck is kicked up a ramp which makes an angle of 30 degrees with the horizontal. The graph below depicts the speed of the puck versus time. What is the coefficient of friction between the puck and the ramp? Solution for problem 19. Here we have graph speed versus time, and from this graph we can find what is the acceleration in the way up and down. Obviously, initial part is part of up, and the final part is when puck is going down. And there are two equations to describe this motion. When the puck is going up, we have an expression for acceleration a1 equal negative g sine theta, which is gravitational part, plus mu cosine theta, which is from force of friction. When arc is going down, we have A2 equal G multiplied by sine theta. Now gravitational part is going to the same direction as the velocity, and minus mu cosine theta, force of friction going opposite direction. And from this graph we can find what is the relative units for accelerations, which are slopes. We have A1 equal -2 and A2 equal 2 over 3. Now we can use these numbers and we can divide the first equation by second equation. So we have sine theta plus mu cosine theta over sine theta minus mu cosine theta. That's equal this expression, and that's equal 3. So we have this equation, and after all we have mu equal 1/2 tangent 30 degrees, which is approximately 0.29. And this is the answer D. That was solution for problem 19.